They had to mobilize massive numbers of workers. They had to create craft skills and differentiated labor. They had to manage the storage bins and the distribution. It required a new communication revolution to organize agriculture, and it was called cuneiform writing. Everywhere hydraulic agriculture originated, in the Middle East, China, India, Mexico, with the exception of Peru, independently, human beings created writing to manage agriculture. Communication and energy revolution. We store them with hydrogen, which is a carrier, so you can use it for transport, but convert it back to electricity. It is like digital. It's a universal storage carrier. Then what do we do with the surplus energy we don't need in our homes, office, factories? This is where the distributed communication revolution converges with distributed energy. Because we have now what we call second generation IT. It's the cutting edge of IT, productivity. It's called grid technology. Advanced in the US, the software, European businesses are 18 months ahead on the operations. Why? Because America beat Europe up on first IT. We went way ahead of you on productivity per hour from 95 to 2002. You were determined not to fall behind. How does this work? We can now take tens of thousands of little teeny desktop computers. The software connects them all over the world. And they give us much more distributed power by a magnitude compared to the power we could get with the most centralized supercomputers that exist on Earth. We can take that technology now to the transmission lines and the power grid. So that if we imagine millions and millions and millions of buildings loading all the energy that's distributed across the planet, storing it in the form of hydrogen, which is like digital, a universal carrier, and then moving it to each other across smart power grids, that power, my friends, is far more than we could ever have gotten with the most powerful coal-fired power plants or nuclear power plants or oil-fired power plants in the world. This is the lesson that the big media didn't understand with distributed communications and collaborative open source like Linux and YouTube. It moves very quick. How long? We're going to have to go through the painful early adoption process. A lot of the startups are going to suffer. It's going to be 20 years to build the juvenile infrastructure. By 2020, 2025, we'll have the juvenile infrastructure in place. If we are on mission here, by 2035 or 40, we should have a mature infrastructure in place. We're going to have both the old centralized power still with us, but they're going to wean down. We're going to have the new distributed power coming across grid, weaning up. Somewhere there'll be a turning point, I think. I mean, we're all guessing, but if we do this right, there's no reason why we can't have a turning point by 2035. We have to get to zero emission. 2 degrees doesn't do us any good. As Nicholas Stern said yesterday, we have to get to zero emission. No one's talking about that yet. I know, advise Brussels. We're not talking 1 degree. The revolution you're engaging in this room, you, the frontier, the business community, you're going to get us to zero emission. 5% of the energy, that's all. They're grandfathering out. They're old. Does anyone here think we're even going to replace the existing 439 power plants in the next 30 years? China, which is the biggest buyer, has 11 plants. They're going to quadruple. It's only 44 plants. But to have any impact on climate change, you'd have to have 20% energy, at least, from nuclear power. That's 2,500 nuclear power plants. You'd have to put under construction 3 new nuclear power plants every 30 days for the next 60 years to get to 20%. Now, it gets to the question of materials. Our International Atomic Energy Commission says we run to uranium deficits with the existing plants by 2025. We could take the uranium and put it into plutonium, then we got a security risk for the whole world. Then there's the question of a real key material called water. Do you know that in France, the quintessential nuclear country, 40% of all the water consumed in all of France is consumed that goes into cooling the nuclear reactors? 40%. Wow. It comes back heated and dehydrates the lakes and streams. There isn't enough water to build these power plants. We don't know how to get rid of the waste, and we can't afford the price of the uranium. Let me deal with coal just for a quick second. Coal sequestration you hear about? We'll go to coal-fired power plants so China can have its way and everyone else. We'll even get hydrogen from the coal, black hydrogen. We'll bury the CO2. I've been skeptical for a long time. My global team, some of them you'll see on the white paper, they're European Americans, put together California and other programs. They said this is not probably commercially viable in any time frame we know of. But even if it could be commercially viable, how will we bury this amount of CO2 under the ground and under the oceans forever with no leak? We're a wet planet. The plates are always changing. The idea that we won't have catastrophic release is really naive. Now, the reason I say this, 2 weeks ago, the heart of President Bush's program for black hydrogen was his Gen Future CO2 sequestration project. They abandoned it 2 weeks ago, front page New York Times, not commercially feasible. So if nuclear isn't probably going to give us much, I think they'll build 50, 100 power plants. I doubt they'll build 200. That won't even help us get back to 5%. And a CO2 sequestration, I think clean up coal, but I'm not sure we can do it. It means we have to even be more aggressive to getting out of the subsidies for the old industries and move into the new. Okay, yes.